Hello everyone, so in this video let us talk about three problems. Yes, so the problems are best time to buy and sell stock part 2, part 3 as well as part 4. So I've already made a video on part 1, so if you haven't checked it out I will link that particular video in the description of this particular video, so go check it out. And in this video we'll talk about the next three problems. So stay tuned, these all are very important problems and it will help you to understand each topic one by one such that you can use the information in this problem to solve different types of problems as well. So the problem statement goes like this for the second problem, that you are given an integer array prices where price of I is the price of the given stock on the ith day, as you can see in the input. Now on each day you may decide to buy or sell the stock. Now you can hold at most one share of stock at any given moment of time. However, you can buy it immediately, sell it on the same day as well. So return the maximum profit you can achieve. Okay, let us take the first example so that it will become more clear to you. So the example is that 7153. So 7153, and the next one is 64. So 6 and 4. Now what you can do is that let's say that if you buy on the first day, then because you buy on the first day, the total amount of years spent to buy the stock is 7. Now if you sell on any other day, you will incur a loss because like all the other numbers are smaller. So it's not better to buy on the first day, you will just skip on the first day. If you buy on the first day and sell on the second day, the total profit you got is 4 because you buy at the value of 1 and you sell that stock at the value of 5. So total profit you get is equal to 4. Now similarly, if you buy, because when you're buying, you cannot buy more stocks. So now you have sell that stock. Now you can again buy that stock. So you can buy at the price of 3 and sell at the price of 6. So again, you have the profit equal to 3. And after like iterating over all the particular days, the total profit you have gained is 4 plus 3 because now you cannot, like, even if you buy at this point, you cannot sell any further. So it's not better to buy here. Total profit you get is equal to 7. And that's the overall answer here also, 7. So now how do you come up with this solution, or how you come up with this particular logic? What you can directly observe here is that for every given ith day, okay, you have, like, you can see that you have two options. Either you can skip it, okay, either you can skip it, like you do not take it, or you can do some action over, or you can do a transaction over this particular day. By transaction or any action, I means that if you are not holding any stock, you can either buy it, and if you are holding some stock, you can either sell it. Okay, so you can either buy it or you can sell it. Okay, so you can do an action, that is these actions, or you can just skip this particular day of share and just move to the next day. So these are the options you can do. So what you can directly observe here is that for the action, so you can, so what are different states? So for any given state, if you want to do, so it's like some sort of a DP problem. So in this DP problem, how can you define out a state? So for me, a DP problem is just find out a recursive solution for that and just do a memorization of it. That's it. Because applying memorization is just a two-step. You just have to write down 2 lines and then the recursive formula, like function, will just be memorized, and after like you memorize it, it just becomes dynamic programming problem. So it becomes very simple. So you just have to first understand how to find out a recursive solution for any problem, and then you can directly just convert it to dynamic programming problem. So for a recursive problem, what you can see here is that you have to first define out what is the different states for which you have to do the like dynamic programming approach. So what you can directly see here is that I have days like till the ith day, because you have to see how many profit I can get. So till the ith day, how many profit I can get. So ith day profit, and till the profit also you have two states. Either you have a stock till this point, you have a stock at the ith day, or you do not have a stock, So which means that you have some sort of a DP matrix, I comma state. This state is like either you have the stock or not have the stock. So because if you have the stock on the ith day, you can obviously sell it. If you do not have a stock on the ith day, you can either buy it or like just leave it. So these are different state values. I'll show you the code part so that it will become more clear to you. But if once you have defined out your states, you can just write down the recursive function. For the recursive function, what you will do, you can just iterate over this array from left to right. Okay, and you can also keep count of a variable, that is if you have bought the variable or not. So buy. Okay, buy a stock or not. Initially you have not buy it, so the answer is, let's say, 1, that you have one stock to be buy. Okay, then what you can do here is, at every position you have, either you can leave it. So if you just leave it, you move to the next ith day and you have still one more stock to buy. Or if you're buying this, if you buy this stock, particular stock, you are taking the stock value. So let's say that you have a portfolio of value. Portfolio, by portfolio I means that how much money you have. So let's say that if you buy this particular stock, you are buying from the total amount of, let's say you have a wallet in your account, so you are subtracting -7 because you're like buying this share. Or let's say that you're buying this one share, 1 rupee share, you're buying this share. So if you're buying this share, your total portfolio will decrease by 1. But on the next day, you sell out this share by this value. So if you sell it, you will obviously gain some value. So total value of the portfolio will increase by 4. And that's the actual profit. So what I hope you understand, that if you buy some stock, the total value of your output or the total profit you have like will be decreased. And if you like sell some stock, you have like your total value of the portfolio will increase. And that is the overall thing that you have to keep track of. So let's move on to the solution part so that it will become more clear to you. So what I've done here is that you have initialized the prices, memset a DP, like let's say matrix with the total. You can just see that you could have also created this and passed it through the function call as well, but it's better to like just make it a global variable if there is not much constraint over the what you can say, space. Okay, so it's 310 so 310 and because there are two states, so 2. And then I call the solve function with 0, which like I start from the 0th day, so like the 0th index day. 1 means that I have still one more stock to buy, like I can buy that stock. And prices is the prices area that you have. Now in the solve function, you just see that so it's a recursive function. And recursive function, you always have to first define the base condition. The base condition is that if you go out of bound, if there is still no more days on which you can do trading, so like you will return 0 because you have nothing much profit you can gain, so return 0. Else you have to find out the profit. Now if you have already seen this particular state, that is I and buy, you can return that state value. Else, so this is one of the way, so this line has to be added and this line has to be added when you have to do like apply memoization to it. Else the whole code is just recursive code. So you have two state. Either if the buy is equal to 1, buy equal to 1 means that you can buy a stock because you have still one more stock to buy. So what you can do is that you have two ways. Either you buy this stock. If you buy this stock, the total value of your portfolio, so prices will be negative, so you add the total value of the ith price you are on, that is you are buying this stock, so that's negative value, and call this solve function again with I+1, and now you have bought this stock, so now you have no more stock to buy, so you only have the option to sell, so return 0. Like this value is 0 because it should be either 1 or 0. 1 means that you can buy a stock and 0 means that you have a stock in your hand, you can only sell it. Okay, and then price is ready. Or else you have not buy the stock. If you have not buy the stock, the total value, the total profit or anything is 0 up till now. Also you call the solve function again with I+1 and still you have one more stock to buy, so and the price is ready. And whatever is the maximum value of both of these states, you return the maximum value in profit. Else, if the buy is not equal to 1, which means that you have a stock in hand and you have to sell it, so you have again two states. Either you sell it, so if you sell it, the prices value will be increased, like plus added in the solve value in the profit one. You go to the next state, and now because you have sold it, again you have opportunity to buy another stock in the later time half. So you can again make your equal to 1 and prices, and if you have not sold it, it is again 0, and you have still not, like if you have not sold it, you have to again in the later half sell it, so you do not have any stock to buy, so it's it's not equal to 1, and the same thing, and you have to find out the profit, like the maximum for both of the cases, and before returning the answer of the profit value, you just have to store that into the DP table. That's it. So these two lines will like before returning store the state value, and if you have seen the state value, just return the state value before, like instead of computing it again and again. That's the overall solution for the second part. Let us move on to the third problem, that is best time to buy and sell the stock, part 3. So you're given an array prices where prices of I is the price of the given stock on the ith day. That is fine. Now find the maximum profit you can achieve so that you can only complete at most 2 transactions. So in the previous example, you can like do any number of transitions, but you can hold at most 1 stock. In this, you have to do like at most 2 transitions only. Okay. Also note that you may not engage in multiple transactions simultaneously. What it does actually means that you cannot do that. You first buy a stock and you again buy a stock and then you sell a stock and then you sell a stock. You have to do this transition in a completed manner. So you have to buy a stock, then sell it, then buy it, and then sell it. Okay. You cannot just like do this in this manner that you have. Okay, if you just delete out this whole thing. that if you have the stock value that is this 71, let us say example, that is 3350. So 3350 and then 0314, because you can do at most 2 transactions. It cannot be that you buy at this 0th point and you again buy at the 0th point and sell it one at 3 point and one at 2th point. No, you cannot do that. So you have to complete the one transaction, that is you have to buy it and then sell it. So like let's say you buy at this point, sell at this point, and you buy this point and sell at this point. So you have to complete total transactions. So you have to find out again the maximum profit you can get. So now in the previous example, what you can see here is that you can do at most 2 transactions. So what you can directly see here is that let's divide this transaction into sub half parts. So each transaction means that you have to buy and sell, buy and sell. So these transactions consist of how many trading you do. Okay, by trading I means that you either buy it or you sell it and then you again buy it and then you sell it. So you have to do this in this exact same order. Okay, so instead of taking out 2 transitions, you have to do 4 steps. Okay, you can see that you have 4 steps to be done. Now what you can do here is that, let's say, so you have 4 steps. So what you can do in this function call, you send 4. Okay, when you are sending 4, which means that 4 is mapped to, let's say, buy, because in the first state you have to buy. So and then when you have bought it, the number of steps decrease by 1. Because you have done one transition. By transition means that you have done one trading operation. If you have done one trading operation, the number of trading operation decreased by 1. Now you have 3 trading operations left. Okay, you have 3 trading operations left. Okay, not buy and sell, just 3 trading operations left. Now in the third operations, you have only the operation to sell, because you have bought it, so sell it. Now you have done one more trading operation, so it comes down to 2 operations. Then you again buy it, it comes down to 1, you have to sell it. So what you can directly see is that all the even numbers are mapped to buy and all the odd numbers are mapped to sell. So what you can directly do here is that you will do the same thing. You have to make a DP table and then you have 4 different buying states. Not buying state, like trading states. So it's like a DP table of the ith day. On the ith day what you will do and the state. By state I mean that what is the trading state on which you are. Like whether it is an even number or odd number. If it is an even number, you have to buy at that particular point. If it is an odd number, you have to sell it. And then it's just like the previous problem. By previous problem, I mean that on the ith day, you can either skip that particular day or you can buy that particular, or you can buy at that particular day or sell at that particular day, depending upon the ith value. And you have the constraint on the number of transactions as well. So on the base case, what you can directly do is that when the number of transactions or the number of actions you can do becomes 0, because you have 4 actions to be done. You can buy, sell, buy, sell. So because the total number of, so this is one transition and this is one transition, because you can do at most 2 transitions. Now if the number of transitions or the number of actions becomes 0, which means that you have still no more actions, so you just return at this point. So that is one of the base case you have to add, that if the number of actions you can take becomes 0, you cannot do, or no, like you will not do any more trading. So if you cannot do any more trading, you will just return at this point. That's the fun thing. So I'll take it on to the code part so that it will become more clear to you. So what we have done here is that we have just do the same thing, mem set a DP table, that is this particular constraint, what is the maximum ith value I can get, and the value of 5, because number of states I have is 0, 1, 2 and 3. 0, 1, 2, or maybe what you can see here is that I have sent from 4, so 4, 3, 2, 1. So there are like 4, 3, 2, 1. So there are 4 states, that is 4, 3, 2, 1. Okay. So in this solve function, we have send on the ith day will start at the 0th day, and we have 4 transitions to be done. And this is the prices array. Okay. Now this is the base condition. The base condition are 2 base conditions. Now that either I will go out of bound, that I do not have any more days to do trading on, so I will return 0. Or else my transactions or the number of actions I can do becomes 0. If that also becomes true, then I will return 0. Okay, else I have to do that. This is the DP like whether I've seen this state or not. If I have not seen the state, or if I have seen the state, return the state value directly. Now if I have not seen the state, I have to calculate the state value. The thing is that either I have to buy or not buy it. Like either I have to not, so let's say that I should not want to take this particular stock on any action. So if you don't have to buy it, I will just move on to the next day. Number of transactions remain the same and prices array is there. Or else if you want to do any action on this day, so either you do an action or you do not do an action. If you do not do any action, you just move to the next day. If you want to do an action, you have to understand that what action you can do. Either you can buy it or sell it. Buy or sell depends upon like whether the day is even or odd. So if it is an even number, then you should buy, else you should not buy. If it is a like, so you just do a mod of 2, which means that whether I should buy or not. If you should buy this day, what you'll do, if you're buying this day, your total portfolio value is decreasing by this, and you just go to the next state, and the number of transactions decrease by 1 because you have done one transaction, that is buying or selling. Both are considered to be transactions. So if you have done one transaction, decrease by 1, go to next state. Or else if you want to sell it, you have to like add the prices value in this total value, go to next transaction decrease by 1, and that's it. And you just have to maximize like what is the, like either you don't have to buy or you have to do a state action. So if you any one of them which is giving the maximum answer, you just return on the maximum answer value and just store that in this particular DP state value. That's it. That is the overall solution for this like best time to sell and buy a stock part 3. Okay, let us move on to the fourth problem, and the fourth problem is like 95% similar to the third problem as well. That in this problem, the question, as you can see it, you can do now, you can do at most k transitions. In the previous example or the previous problem, you have to like, you can do at most 2 transitions. Now you can do k transitions. So what is the actual difference here? Now in that problem, in the previous one, what we have done is that we have taken that if we have 2 transactions or two transactions I can do, then we have 4 actions I can do, like buy, sell, buy, sell. Similarly, if I have k transitions, which means that I have 2k actions I can do. So the overall thing is that this solve function is almost like, this is the 100% same only. So in this problem, as you can see, this and this, the solve function is same. But when we are calling this solve function, in the previous example, we are sending 4 because we have at most 2 transitions. But in this, we have k transitions, so we will send 2 into k. Okay, and this is the same thing. And you have to update your constraint value also, because in this the constraint ith value can go up to 10 over 5. So I've taken the 10 over 5, and because they have at most like 5 actions also, so this is 5. In this I have at most as you can see like 100 like k is equal to 100, so I have at most like 200 actions, so it is 202, and the prices area is 1000 to 1005. So I updated this DP state value as well as for which number of actions I want to perform. So this solve function is remain the same, because we just have to understand what is going inside this. This actually help us to find out at any ith day I have, either I can like buy it or not buy it if I have still any transitions left, if I have still some actions left. So at any point, if I do one action, I just decrease my transition by 1. And this is the base case, that if my transition becomes 0, I return. And because we have k like 2k actions, so it will become 0 at any point of time when we have done all of the 2k transitions, then it will turn 0, and that's all. That's the overall logic and code part for all the 3 problems. Thank you for watching this video till the end. I will meet you in the next one. Till I keep coding, and bye.